give you x's and p of x's. Together, that represents all the data. 4% on my list was 21. 24%, blah, blah, blah. So together, they represent the data. So I got to put this in, 0.0 par. Why didn't you do this earlier, Jeff? I was busy. All right, and then I can go to L3 if you want to. You can make it L1 times L2. So that should hopefully look familiar. All right, I'm not going to write this down. And then L4. I do L1 times L3, don't matter. Oh shit, Jeff. Well, it's kind of nice to have it. Oh, look at me not writing things correctly. So L1 times L3, bam. What am I doing? Oh, me. There, okay. Huh? I don't know yet, we'll find out. Now, this piece will always be true. It's gotta be, it's gotta be true. I love it, Jim. Why is it not working? But you gotta check to make sure, just in case. In the homework, you gotta make sure that there's not some little tricky thing. Just make sure they're all between 0 and 1. They have to be probabilities. And then you gotta check to see if this is true. In this case, they do add up to be 1. Well, you better make sure they add to be 1 before you say they do. Okay. So those are the two main things you must state to verify it's a valid, and check it, really check it. All right. This one, at least 25 means 25 or more. Or means add. So you can add all this shit up here, right? Or, so I really want this just to make math sense. All these add to 1, don't they? So 1 minus this is all the rest of the shit. That's why 1 minus the thing it leaves out is a shortcut. So it's sort of like the bigger version of at least 1 being 1 minus none. At least something is 1 minus what it leaves out. Bam! So this will be 1 minus 0.04, 0.96. And if you added all this shit up, of course you get 0.96. Because you know they make 1 all together. Okay, maybe. And then when you add up that, you get, what was it, 40? Was it 40 something?
45.
0.89?
Yeah.
So that's what you get when you add all those things up. And again, just to show you, if you did it and the computer, Jeff, really? What are you, Joe Biden? Oh, computers! Sum of, where am I at? L3, there it is. Yay. And then if I do sum of L4, I get my 2410.89, which is the sum of this list. Jeff, you shouldn't write looking at the screen, dude. That's hard. Everybody's semi with me. I think everybody I looked at, you got this number over there. The most common mistake happens right here. What have I done wrong?
Didn't square it.
Didn't square it. There you go. Kind of makes sense. This is before I square rooted anything, so everything is still got squares in it. Even the little mean dude, to be fair. How we doing? We all right? Some of you guys are looking at it like, what the shit? But nobody's saying anything, so I'm going to keep going. So if I do that, 2410, Jeff. 2410.89 minus 45.89 squared. There's the variance. So what you guys got?
Yeah.
304.9979. And then what do I do with that?
Square.
Square root it. They all float. No, not that. It's 17.464. Is that cool?
Yep.
Yes, ma'am.
Sorry, I was done for the first part, but I just wanted to clarify for A, if we just put like sigma and the probability of x equals 1, in this case, since it actually equals 1, would that be?
Of course. Of course. Of course.
And then if it was like 0.999, you would want to.
You need to write that, and then so if it did make it 0.99, you would say sum of p of x equals 0.9999, which is approximately 1. So you're showing me that you checked it, and you're showing me you know what it's supposed to be.
Okay.
Does that make sense? Don't just say this shit, because then I'm like, does it always have to be that? No, it always has to be that, and that's close enough. And same thing for 1.00001. But if you get 0.92, oh, hell no. I almost did. Oh, fudge. All right. So what goes in the middle here? So this thing, I keep doing this. This question. God, Jeff. So the mean goes in the middle. And why do I keep doing this? Because there are a lot of theorems about the percentage of data that's within so much. That's why we're able to make doors a certain height and have a percentage of people that will fit under them without hitting their head, and so forth. Size of the airplane seats and all that kind of business. So if I take one step up, that gets me to where? 63 point blah blah blah, whatever, 3, whatever. And then if I take one step down, 28 point stuff. And then I always do this for myself. What numbers did I catch in there? All the 40s and the 50s. The 21s and 25s are over there. The 65s and 100s are over there. If I caught all the 40s, that's 23% of the data so far. I also caught the 50s, which is an additional 18% of the data. So I caught a total of 41% of the data. Yes, ma'am.
For the standard deviation portion, if we don't have it at 3 decimals, would you take off points?
If you have more decimals, that's fine.
But if you had less than?
Then you'll lose points.
Okay.
Because standard deviation has to be at least 3 places. Probability has to be, so that's why I said earlier semester, make everything 4 places and you've got your ass covered. Right? If you want to, it's up to you. All right. How many kids think they'll retire? Well, how many kids total are there?
1,200.
1,200. Some of you guys are like, how do you know that? Because I said that way up there. 1,200 kids. What percentage of them think they'll retire before 65? If you add up all these things, you get who what? 0.69? So if I multiply that, 69% of 1,200.
828.
8 who?
828.
828. What's up? Where are we at? Are we all right?
You added 21 for 65.
Yeah, before age 65 would be these. Before age 65.
Right.
So it'll be these. No, it's 69. Yeah. All right, I like it. I like it. What was I going to say? There was one other thing I was going to say. Oh! Real quick, watch. You guys see how I got all the data in there? Can somebody tell me, I said this earlier, where's the data in those lists? Where is the data? Which list is, which?
L1, L2.
Thank you. I love it. L1 and L2 together are the data. How many variables? I've asked this question before and you always tell me the wrong thing, but how many variables are in there? 1. Kick ass and age. I asked them one question, right? So that's one variable. I could do one variable statistics. Remember, that's the one that tells me all the answers I want? So if we do one variable stats, but what do I do it on? L1 and L2. So I told you earlier, what is probabilities? Relative frequency. What's my frequency list? L2, that's where they are. Calculate, look at the shit I get. Does that look familiar? Mm-hmm. And I know I always do this and somebody's like, why do we do all that shit then? Because that's you learning and this is you checking. Two different things. Look at what it says here, n is 1. What do you think that really means? The sum of the probabilities is 1. That's what it means there. Alright.
Are you going to be this nice on the test, like the way you...
No, hell no. You know I'm not going to be that nice. My worksheets are nice. My quizzes are so mean. My tests are even meaner. Yes?